Hello. You should have your book that we just wrote on, and you should have your note packet here. We are in a new unit. We are dealing with exponents, and like I said a little bit ago, you're going to be working with zero negative. So I have put some of this information in our exponent book. So if you would open your exponent book to the first couple pages, I have defined already for you right here base exponent power. Okay, so I'm going to write here C, we called this Book of Exponent Rules, C Book of Exponent Rules. And that way you can go back and take a look at that. Then numerator, denominator, product, and quotient. Let's work with numerator and denominator deals with a fraction. So numerator is the top number in a fraction. Denominator is the bottom number. So I'll refer to those two quite a bit. And of course, product versus quotient. Product is the result of a multiplication problem, or I might put MULT, multiplication in parentheses. Quotient would be the result of a division problem. So with exponents, a lot of exponents have to do with multiplication. So we will be using that term quite a bit. Another really important part of exponents is it's all about simplifying them down to a more usable format. So there are 6 items here when you're simplifying, and I'm trying to guide you so that you know when you're done, because oftentimes I find students aren't really sure what they need to do. So we're going to make a list here. And right underneath the title here, I'm going to write, you know you're done when. It's kind of the title here. You know you're done when ... You know you're done when you've hit these 6 items. So item number 1 is, there are no negative exponents. There are no negative exponents. There are no negative exponents. So we are going to simplify those negative exponents and turn them into positive exponents. There are no exponents left on numbers. There are no exponents on numbers. So if we have like 2 to the 5th, we'll actually multiply that and figure out what 2 to the 5th is. Thirdly, there are no repeating letters. There are no repeating letters. If there are any repeating letters, we will combine them with exponents. The 4th one down, there are no parentheses. There are no parentheses. No parentheses left. So we will take care of simplifying those. Number 5, there are no zero exponents. There are no zero exponents. No zero exponents. And then finally, you have reduced your fraction. You have reduced your fraction. And by reducing, I mean like 2/4 is reduced to 1/2. So this is a good checklist. I will come back to this checklist a lot, and this is something good you can come back to see if your problem is simplified. Okay, if you would, let's go to page 2 here. Go back to the top. So summary of zero exponents, and we wrote that in your book right here. So if you want to, you could recopy this over to your notes. But we could, I think I might just recopy this first sentence, this big area right here, because it's pretty quick to recopy. So in summary, anything to the 0 power is 1. Anything to 0 power equals 1. Okay, seems pretty easy. And the reason I want to talk about that is I want to go through this table with you because I want you to see the pattern. Everything in math is about a pattern. So what I'd like you to do, if we look at the 32 to 16 to 8, the pattern here is we are dividing by 2 every time, right? Because 32 divided by 2 is 16. 16 divided by 2 is 8. 8 divided by 2 is 4. So I'm going to write maybe divided by 2 out to the side. 4 divided by 2 is 2. 2 divided by 2 is 1. So I'd like to stop there for just a second. And what I want to do is on this side, I want to write these numbers in terms of powers. And what I mean by that is, if I took 2 and I raised it to a power and I ended up with 2, that power is 1, right? Because 2 to the first power is 1. If I took 2 and raised it to a power and the answer was 4, it would be 2. If I took 2 and raised it to the third power, 2 times 2 is 4, 4 times 2 is 8. So can you see my pattern here? 16 would be 2 to the fourth, 1, 2, 3, 4, and then 32 is 2 to the fifth. So in order for you to see why anything to the 0 power is 1, let's go backwards with our pattern. This exponent is going down by 1, so this should say 2 to the 0 power. And see how 2 to the 0 power is 1. The reason is the next higher power of 2 to the 0 is 2 to the 1. So if I take 2 to the 1 and I want to go to 2 to the 0, I'm simply dividing by the base. And any number divided by itself will give me 1. So anything to the 0 power is going to be just 1. So let's apply that to these problems. Now, 4 times m to the 0 power. You need to really think about this as being 2 parts. This is really 4 times m to the 0. So m to the 0 is the only thing that is equal in 1. So this really simplifies out to be 4 times 1, which is 4. Now, this is not going to be all, this entire thing doesn't turn into 1 because 4 is simply, remember how I said before, back to our book? If a constant or a variable does not have an exponent, it's automatically a 1. So when I separated it out, this is really 4 to the first times m to the 0. And 4 to the first is still just 4 to the first. Okay, same thing here. P to the 0 over 3 to the first. So p to the 0 power, this is equal to 1, but 3 to the first is just 3. So this turns out to be 1/3. Okay, next example, x to the 5th over times 6 to the 0. 6 to the 0 is equal to 1, but x to the 5th is just x to the 5th. So this is x to the 5th times 1, which is really just x to the 5th. So be careful when you raise something to a 0 power. It's only that item next to the power of 0 that is going to be a 1. So I'd like you to pause the video and do these 4, and then come back and check to see how you did. So go ahead and pause the video now. Okay, let's see how you did. The first one here, you should have gotten 1. Since it's in parentheses, it's all to the first power, all going to be 1. Both of these are going to be 1. So this is like saying 1 to the 1, so the answer is, or 1 times 1, so the answer is 1. This is going to be 1 times x to the 3rd, so the answer is x to the 3rd. And this is going to be like 2 to the 1st times r to the 0 times m to the 3rd. So the only thing that turns into a 1 is r to the 0 power. So this is going to be 2 times m to the 3rd. Okay. Let's move on to negative exponents. So you can see negative exponents are basically exponents with negative numbers. Now I want to go back to my table and talk about why we wrote this down in our book. We wrote in our book, to turn a negative exponent into a positive exponent, cross the line and change the sign. So that's supposed to be kind of a catchy way for you to remember it, but let me show you why that is. So back to our pattern here. On the left column, we divided by 2. So let's keep dividing by 2, but I want you to write it as a fraction. So 1 divided by 2 can be written as 1/2. Okay? 1/2 divided by 2 is 1/4. 1/4 divided by 2 is 1/8. So you can see the denominator is getting divided by 2. 1/8 divided by 2 is 1/16, and then we have 1 over 32. So let's extend our pattern on the exponents here. 5, 4, 3, 2, 1, 0. So the next number smaller than 0 is negative 1. And then 2 to the negative 2, 2 to the negative 3, 2 to the negative 4, and then 2 to the negative 5. So let's look at actually 1/4. I want to talk about that down here. So 2 to the negative 2, I said, is 1/4. So in our book here, I said you could cross the line and change the sign. So let me show you why that works. If I take 2 to the negative second, I can write that as 2 to the negative second over 1. So if I cross the line and change the sign, that is going to be 1 over 2 to the positive second. And if I go ahead and do 2 squared, I get 4. So I am getting a 4th. So these exponents, or fractions I should say, can really be written as 1 over 2 to the first. 1/4 can be written as 1 over 2 to the second. 1/8 is 1 over 2 to the third. So can you see in my fraction, it's 2 to the first, 2 to the second, 2 to the third. Continuing that pattern, 1 over 2 to the fourth, and then 1 over 2 to the fifth. So you can see that these negative exponents simply switch to the bottom and turn positive. And then when I go ahead and do the math, do 2 to the fourth, I get 16. Okay, so that's kind of the why behind it, but let's focus on just sort of actually simplifying. So I want you to have in your mind, cross the line and change the sign. So, first example, h to the negative second. I'm going to encourage you to turn these into fractions by putting them over 1. So it says here to cross the line and change the sign. So when I do that, that's going to switch to the bottom, and there needs to be a 1 will be left on the top. So this will say 1 over h to the positive 2. So I cross the line and I change the sign. Number 2 here, it's on the bottom, so I'm going to cross the line and change the sign. So it's going to be a to the positive 3 over 1, or we just usually write that as a to the third. We don't necessarily need it over 1. Now, this example is really 5 times h to the negative 2 over 1. The h is the only thing that crosses. So I'm going to take the h and cross it down there. So the 5 has to stay, because it doesn't say 5 to the negative 1, and then h to the second on the bottom. Cross the line, change the sign. Okay? Second, this example here, the a to the third is the only thing that switches. So the 7 and the 4 don't move, but I need to switch the a to the top and make it positive. Okay, same thing here. This is really 4 times w to the negative 80th. So the w is the only thing that switches down. So this simplifies to 4 left in the numerator, w to the 80th. Okay, I want you to pause right now, and I'd like you to try these last 3, and we'll see how you do. So go ahead and pause real quick, and then come back and check yourself. Okay, let's see how you did. You should have 7 times e to the 29th here. Remember, the 7 stayed, the 7 didn't move. This one should be, now put it over 1 if you get confused. This should be negative 9 staying in the numerator. The x comes down to the denominator and becomes positive. This one, the p is the only thing that moves. So it's going to end up being 2 times p to the 100th over 13. Okay, so let me give you a quick summary here. When negative exponents are on the top of the fraction, you are going to move it to the bottom and make it positive. Move it to the bottom and make positive. Cross the line and change the sign. When negative exponents are on the bottom of the fraction, you're going to move it to the top and make it positive. Move it to the top and make positive. Okay, so I'd like to finish off. I have 4 more examples for you to try. So I'd like you to go ahead and pause the video, try these 4, and then come back and we'll check and see how you did. So go ahead and pause the video. All right, so we should have here 3 over y to the second power. Second one is going to be negative 4 times k to the fourth. Now this one's a little tricky. This one is going to be initially be 7 over 14 times r to the third, but 7 over 14 reduces down. A 7 goes into both of them. So it really turns out to be 1 over 2r to the third, because 7 over 14 is the same as 1/2. So I want to reduce my fractions down. Okay, this one is like saying 9 times g to the 0 times n to the negative fourth. So I got two things here. G to the 0 power is 1, and n to the negative fourth switches down. So remember, all of that's really over 1. So I'm going to have a 9 left in the numerator all by itself. G to the 0 is 1. I don't need to write that down. The bottom is n to the fourth. All right, so I'd like you to go ahead and get your assignment and practice this, and then we will check the next day with a key.